Hello everyone. I'm Chris Furlong. I'm the product manager, and I'm joined by Tim, my architect.
Yeah, my name is Tim Dörnemann. I will run the second part of the show, including some live demos, so hopefully it will be exciting for you as well as for us.
So just what we're going to cover, I wanted to take the opportunity, because DataHub it's about 4 years old. It's one of the younger products in the Cumulocity family. Just to give you a bit of an update on what we've done in the last year and a few things we've got coming very imminently. If you sat in on the session that Nick, Rob, and I did yesterday, we talked a little bit about connectivity updates and some new connectivity options we have with DataHub. I want to expand on that. We kept it quite short on that session. And then we're going to talk about this shift towards a data lakehouse architecture that we're going to make. So firstly, we'll define what we actually mean by that. And then Tim's going to show you some of the cool stuff that will actually enable you to do. So what have we done in the last year? We've upgraded DataHub to support the new time series storage that Jane and the team delivered. So that's much more efficient with inside Mongo. We had to make adoptions to DataHub to support that. That's already done, in use by customers. We had to make a lot of changes to what we called mixed data types. So for those not that familiar with that, that is doing things, crazy things really, like putting text and numeric in the same field. I can go into that in a lot more detail offline, but we had to change the way DataHub handles that. So if that's something you've already got a problem with, we have some additional material that talks about that. And quite a common requested feature was select how often DataHub offloads. It may seem quite small, but historically DataHub offloaded once an hour. We were seeing customers whose devices actually only uploaded once a day, and they wanted a bit more control. And actually for us, you know, we're not running things that do nothing if they're only putting data in once a day. We also upgraded to Dremio 24. For those who are familiar, DataHub is powered by an OEM of Dremio. So we brought that up to date. It brings with it some query performance, depending on your query profiles, but on the TCP benchmarking, it's quite impressive. Your mileage may vary on that. And also, that enabled us to reduce the number of API calls that we make to your data lake. That, in turn, will reduce the cost of owning that data lake with DataHub. Because the data lake providers charge for API calls, we make less, the bill goes down. And again, we kind of acknowledge that with DataHub, you don't spend a lot of time in the DataHub UI. And we don't want you to, really. You go in there, you configure things, and it should just run. But we want it to be a lot more proactive if something went wrong and needs your attention. So DataHub will now raise alarms, Cumulocity alarms on job failures, so there's more visibility around what's going on. What's coming imminently? Again, kind of acknowledge you don't spend a lot of time in the UI, but when you do, we want it to be a lot more visible about what DataHub is doing. So we've overhauled the homepage of DataHub, so you can see how many jobs have run, how many are running, how many have failed, and get an overview of what DataHub is up to on that tenant. And again, another area which was a little bit harder to do in DataHub than we wanted was how to handle some of the more complex data in Cumulocity and get to the values you actually wanted. So we put a lot of work into the UI around getting to these additional columns. So again, all about making it easier to get the data out of Cumulocity into the lake in the format you want. This is coming very, very soon, so it'll be coming on the public cloud through CI/CD. We talked about this yesterday, and no apologies for reusing the slide, but one of the things Dremio 24 brings for us is improved connectivity to Power BI. So Power BI, since about July 23, has native Dremio connectivity in it. That's now enabled for DataHub because we've upgraded our Dremio version. And we also have a community-provided widget for embedding Power BI dashboards inside your Cumulocity IoT cockpit. And we are actually seeing customers starting to use that. I can see a couple of Tableau users in the room. Tableau as well also has native connectivity for Dremio, and that's now enabled with DataHub. So that's the stuff we presented when we talked about analytics, but there is some more in here. Dremio 24 brings Apache Arrow Flight, which, as you can see from the statistics, and those benchmarks actually come from Dremio themselves, is way faster for getting data out of DataHub. And this is really going to be impactful for your data scientists. They'll be able to extract data from DataHub, get it into whatever you're using or training your ML models much, much, much quicker. For those who are looking at different kind of data pipelining, and Tim will actually show a little bit of this, there's a very popular product out there called DBT. Dremio 24 enables the use of DBT, and we actually have some customers who are already starting to work with this to do additional manipulation, additional data pipelines on top of their DataHub data. And we do actually have a few Cumulocity IoT DataHub customers who are also Dremio customers. So Dremio 24 also enables what they call Dremio to Dremio. So one Dremio instance can query another one. So for those customers with Dremio, you've got a few more options here on how they can work together. So let's move on to the really big subject here. So I kind of wanted to start with, well, what is a data lakehouse? A few of my PM colleagues thought we were actually talking about a lovely house next to a lake, and I like the vision. And we should have put a picture in of that, but they kind of came up with this too late. So I found a definition, and I can't remember whose definition this is, and I kind of put it on the slide, and I read it, and thought, well, that first part, that's actually what DataHub is doing anyway. It's an open data management architecture. It's flexible, cost-effective, and scalable. That's what DataHub is doing today anyway. So what does this data lakehouse piece bring to it? And again, Tim will go into a lot more detail on this. But it brings data management, ACID transactions, and lets you go even further with the BI and ML kind of use cases around DataHub. Behind the scenes, Tim will talk about things like Apache Iceberg. But at this point, Tim, I think this is where I hand over to you.
Yeah, I guess so. Thank you, Chris. So before I actually start to talk a little bit about the, let's say, backgrounds, and then I will give a demo, I would like to do one of our usual quick polls, just to get an idea how familiar you are with the technologies I'm talking about. So who is actively using data lakes, like Azure Storage or S3 maybe? So a few. And who of you knows about or is using cloud data warehouses like, let's say, Snowflake or BigQuery maybe? Again. Oh, no one. Okay, that's interesting. So then I guess the last question, who is familiar with or using Apache Iceberg is almost obsolete, but is anyone aware of it? Harald, great. Okay. Good. Yeah, so then I guess you will learn something new today, which is good, I think. So traditional data lakes like S3 and Azure Storage are more or less infinitely or almost infinitely growing file systems where you can just put in arbitrary data. They are also called blob stores or object stores. And they offer very little support for building, let's say, write-intensive applications. So it's more or less a file system where you can dump files into. And there's all sorts of problems that you can have with that. And this is the reason why Apache Iceberg was created. It adds an additional layer on top of the data lake, on top of the data files, to help you first manage and organize and track the files in your table. And the project, interestingly, originates from Netflix, the streaming company Netflix. They had issues with things like GDPR compliance, and they also had multiple applications who needed to write to the same table in parallel. So they ran into concurrency issues and all that kind of stuff. And for GDPR and so on, they needed to be able to hide or delete data. And also over time, you know that your application data might evolve, so your schema might change. and Iceberg explicitly supports that. So yeah, we'll go into a little detail later, but maybe first some schematic here. So the typical data lake you currently have, your data lake tables in be that DataHub or in other tools like Athena, only consist of this low level here, the level at the bottom, which is your actual data files. That might be CSV files or org, Avro, or in our case, in DataHub, we use Apache Parquet. And then, optionally, there might be a folder structure on top of that. In our case, we use a hierarchical folder structure. We structure the data by year, month, and day to allow the query engine to prune partitions, as it's called. So to select, when you run a query, which data it needs to read. Because this is a data lake, it doesn't have index structures like databases. So you need other ways of determining which data you need to read. And Iceberg now, first of all, as Chris already said, adds transactions. So you get ACID compliance like in relational databases. And so every operation that alters your data lake, like adding data and so on, is now carried out as a transaction. And a transaction creates a so-called snapshot, highlighted here. And this snapshot has one or more data files, one or more manifest files, which do hold some metadata on the actual data. And then there is a manifest list, basically pointing to those manifest files. And now it's hard to read in the background, sorry. And then there is one metadata pointer, which points to the most recent version. So now let's think of DataHub. We have done 1 hourly offloading. We have a bunch of data now. And then the next offloading comes. Then we run that offloading step. We add a bunch of new files, let's say a few hundred megabytes as Parquet files to the data lake. And the data, unlike now, will remain invisible until the manifest files have been written, the manifest list, and everything is ready. Only then the metadata pointer is switched from the old snapshot to the new snapshot, which gives you all the nice isolation properties and so on. And yeah, that gives us as R&D opportunities to improve the product, but it also holds interesting features that we will make available to you as end customers. But that's the second part. So first part is improvements to the ETL process or offloading. First of all, what we will get is an explicit schema for every table. Currently, the schema is determined on read, which means you just add new data to the data lake, and then the schema, when you run a query, is determined. So it might change over time based on changing input data, but this is implicit. There's no control over it. And in relational databases, as you probably all know, there is an explicit schema. You create that table with a create table statement, and you get exactly those properties here now with Iceberg. And any change, like if you have new series added to your measurements or whatever, will have to be reflected via alter table commands, making those changes explicit as said. But don't worry, this is something the product will do internally, of course. You won't have to run those statements manually, of course. Another very interesting features, especially for time series and IoT applications, because the data inherently is time series for us, is hidden partitioning, or it's also called partition evolution. And here the point is that with Iceberg, the data partitioning doesn't rely anymore on the physical structure in the data lake, so the folder structure, but it's implicit or virtually defined in those manifest files I just talked about. And that will allow us, as an example, to change the size of a partition. So let's say we have some customers where tenants only have a low amount of data, then it makes sense to partition by day or even by month to have a reasonable partition size. But then there is other customers who offload tens of gigabytes per hour, and then it makes sense to have smaller partitions because the partition size determines how much a query needs to read at minimum. So if you have two large partitions, you need to overscan all the time. So there is a correlation between those factors, and we will be able to do that via alter table, drop, and add partition statements. And of course, the robustness will even be increased. Not that we have big issues with robustness, but we get interesting new primitives like time traveling and also rollbacks to earlier states. And I will show that in the demo in a minute. I need to hurry up a bit. We will also get lower metadata costs. That's interesting for end customers, of course, because it reduces the total cost for the storage account for the S3 bucket and so on. And the table metadata is automatically shared in air quotes with other tools. So if you want to query the data via Spark or Athena or whatever, they don't have to crawl the table anymore and determine all the metadata, column names, and so on from the Parquet files. But instead, that information is now explicitly put into those manifest files, which are part, and that's new, of the table itself. And that's really interesting, and many, many tools in the community have already picked up Iceberg. So this is nothing only we are using, but all big tools, Snowflake, BigQuery, Athena, Azure Synapse, all those tools already support Iceberg. So that, I guess, will be interesting for many customers who already have invested in some kind of big data stack. Yeah, let's skip over that. Another interesting property is, and I will keep that really short, currently we cannot append data to partitions we have earlier created. So let's say we run an offloading, and that offloading puts some data for the last hour into the data lake. And then when a new offloading runs, and we have late arrivals, so data where the application timestamp is in the past, we have currently no chance to attach that to the partition where it would belong to because the partition is closed. Not an issue for the majority of customers because mostly the difference between the ingestion time and the application time is minimal. But for some customers, there is gaps of even years because they import data from legacy systems. And that can be a problem in those cases. And so we had to make a hard decision when we started architecting DataHub. And the decision was to not use the application timestamp for partitioning, but to use the system timestamp. So the timestamp we attach when the data is persisted in our database. And as said, not an issue for most customers, but it can be that the query patterns don't really match to the physical structure, leading to suboptimal performance. And I see Harald nodding again. You know who I'm talking about. When switching to Iceberg tables, the good news is we will be able to append data to existing partitions. And in short, this will allow us to use the application timestamp for partitioning, which will then lead to best possible performance for all use cases, which is, I think, interesting and good property. So what's in for you as end customers? I think we have a very interesting feature that we can offer, which is database-like behavior at the cost of a data lake. So storage in a data lake per gigabyte costs roughly 2 cents. If you have a MySQL or a SQL Server database or whatever, the cost per gigabyte is way higher. And what we get with Iceberg is, as said, this asset properties. And so we can offer things like APIs to use, SQL-based APIs, like create table, and then you can decide what schema you want to have. And after that, you will be able to insert data into the data lake. You will be able to update data, and you will also be able to delete from tables. So that might be, for some use cases, an interesting replacement for, let's say, overusing the inventory API. Okay, yeah, we are building that as a feature currently because you can run those statements directly. But every transaction creates a new snapshot, as said, and there is some housekeeping that needs to be done, and we want to automate that housekeeping in the background that you don't have to run it manually. Okay, now I need to really rush. So over to the demo part. Okay, so you can see my screen. I want to show two things basically. First of all, very quickly, integration with dbt, and then the Iceberg feature. dbt is short for data build tool, and it's a tool that allows you to create data transformations that can then be materialized and persisted in your data lake. So here as an example, I have two tables. One contains smart meter data, and the other one contains weather data for the particular region where those houses with the smart meters are in. And what we want to do is we want to build a dashboard where we correlate the outside temperature with the kilowatt readings, just to see if there is any correlation. Problem now is the raw data is roughly, in that case, here 70 million records. 70 million records. And we need to reduce the granularity and join both tables to have them together ready. So now just let me first start the tool. All I need to do is call dbt run. And now this is running live against a tiny DataHub deployment on Azure. That's why it's taking some time. But while we are waiting for the results, I can quickly show you how you model your workflows in dbt. It's all based on plain SQL. So all you do is you create SQL statements. In that case here, I first reduce the time granularity of the data to 1 hour by summing up the kilowatt hours per hour per device. So it's like a simple grouping operation. And then, I hope you can now read that. I have just put in some metadata, some configuration, which is materialized as table, and you will see what that means in a second. And then we have a second model, which joins both tables, the now reduced time granularity meter table with the weather table. We also want to materialize that. And then the third table actually truncates down the now merged data to daily aggregates, because that's then the right granularity for visualization. So by now our workflow has completed, and we can now check back into the Dremio UI. And now here in our data lake, that's Azure Storage, but doesn't really matter. We now have a subfolder, and there is now 3 tables. This is meter by hour, meter weather joined, and then this one is the table that we actually want to use for visualization. Now I quickly switch over. Great, session lost, nice. Switch over to a virtual machine running Power BI. Power BI doesn't run on Mac, that's why I'm using some virtual machine. And now very quickly, I create a visualization which has the timestamp, the day on the x-axis, and then on the y-axis I put my kilowatt readings and my temperature. And now you see we have a result here, but it doesn't quite look right. So the left side, the data looks strange, and also on the right side, the readings don't seem to be right. And that's easy to fix and also easy to confirm, because I have also built some tests. Now I can run, oops, that's the wrong window, obviously. I can run dbt test, and it will confirm. Again, that's SQL that you write to test your data, to provide some data quality tests. And I just put in some simple statements like the amount of kilowatt per hour must not be higher than X by Z and so on. And here we see we have a failure in one test. and that's easy to fix. I'm taking the easiest path here. I will just exclude the data before mid of November in that case, so when the data looked strange, and then basically rerun the workflow. And then the whole data is regenerated, and when I then refresh the dashboard, the result will look better. But maybe we don't wait for it now. I just continue with the demo, and then we get back to it, because we are over time a bit, or will be over time. Second part of the demo is Apache Iceberg. And here I'm now using the Dremio UI again to showcase that. But there's no reason for using this UI. You could run the same statements via our REST API or via ODBC, JDBC, Apache Aeroflight. The API doesn't matter, it's the command. But for demo purposes, it's just the easiest to do it like that. So first thing I will do is I will create a table. Or better. A table which just has two columns, ID and text. Okay, now let's run that. Now that's a good start. I guess it's the empty line causing the trouble. No? I forgot to comment out one of the statements I want to run later, actually. Okay, so now it's done. And now let's check what we have in our table. You guess there should be nothing, but let's check. I need to decrease the size a bit, because otherwise we don't see the results, so it's empty. No surprise. And now I run a bunch of insert commands to fill the data with some rows. And I do both multi-inserts. So this single insert statement here inserts multiple lines at one time. And then we have 3 single inserts. Again, like in any ANSI-compliant SQL database. And that's the key, actually, of the demo. It behaves like a database. That's the key takeaway. So it's running. And you might wonder why it's taking a bit of time. This is the UI. It just submits the queries very slowly. It's not the backend, which is that slow. Now let's run the select star statement again on our table. And what we have created now is a bunch of rows that, when you read them vertically, tell you hello Dublin. And now let's look at some update statements. I just need to comment out the other statements. And now we have in total 3 update statements and 1 delete statement. It's running. Now it's done, and now our table has changed to hello IOG. And again, that's all happening on top of a data lake layer, not in a relational database. I'm not cheating here. This is really running on top of a data lake. And now, just to conclude, I want to show one thing, which is how you can roll back tables to earlier states. So there is, as I said, snapshots, and you can at any time go back to an earlier snapshot, either by really rolling back the table, or you can also query a table at a certain state in time. You can run a select statement with the appendix at timestamp, and then you get in view how the table was before my updates or whatever. But in this case here now, I don't want to show the select, but I want to show rolling back. And for rolling back, I need to find out which timestamps my different snapshots have. Or I could also use the snapshot IDs, but I want to use the snapshot time. And here you maybe can or cannot see we had a few append operations, which were the inserts, and then update and delete are override operations. So I want to go back to the hello Dublin state, which then is this timestamp here. So now I copy that. See. And then I run that rollback table statement. And I just need to put in the correct timestamp here. Yeah, okay, that worked. And that should run pretty fast. It's a single command. And it's not actively deleting data, but it's just resetting the metadata pointer for the moment. And only if we run operations like you might know from Postgres, like optimize and vacuum, the data would actually be deleted. That's why that run very quickly. And now, just to conclude, we run our select statement once more. And now we are back to hello Dublin. That's all. Any final words, Chris?
Toolbox for your data scientists with DataHub. Some interesting new use cases I know a few people in the room are interested in as well, because we can manipulate potentially the data. DBT, I think, gives a lot of potential as well on post-processing, and we may look to see what more we can do with DBT than the integration that already exists in 10.18. But other than, thank you, Tim, and are there any questions?
One last thing. Let me hit the...
one last thing. He's done the Steve Jobs thing.
One more thing, but it's nothing spectacular. I just hit the refresh button. And now you see we have rerun our DBT workflow. We have filtered out the faulty data. And now the left and the right hand look better because the data has been recreated while we were working on the other demo.
Thank you, Tim. Any questions?
Thank you both very much. So, any questions?
That was great demo, Tim.
Thanks.
So the metadata layer in the Iceberg, can you use that layer for doing better materialization of the tables? So can I add metadata information that could then be used to join or do when you're running your ETL workloads to materialize things better? Is that possible in Iceberg?
That's a great question. The metadata actually doesn't help too much for the offloading, but it helps a lot when you run actual queries on the exported data, on the offloaded data.
Okay.
Because then Dremio, the engine we are using, can leverage all that metadata for the different petitions. So there's a lot of small files, and they do hold metadata information like min and max values for the different petitions. So let's say you run a query like, I want all data between yesterday and today. That's filter number 1. That's a time filter where series ABC is included and Z is bigger than 15, let's say. Then we do not need to read the data files anymore, but all we need to do is look at the statistics. If the series has any value which is higher than 15 or lower, whatever your criteria was, and only if the file qualifies, the Parquet file qualifies, it will be read. That was possible to some extent earlier, but it has been improved a lot with Iceberg. So queries run much faster in general. Yeah.
Any other questions? No. Well, in that case, I will just say thank you both very much indeed. That was a really interesting presentation and a really good live demo. Very impressive.
Thank you.